IC-8 small aperture IOL red-green balance refraction. I'm Dr. Karina Vanderpoel. I'm assistant professor at the Southern California College of Optometry at Marshall B. Ketchum University in Fullerton, California. The IC-8 IOL uses a small aperture to extend clear focus across a continuous range of around 3 diopters. Due to this unique method of action, current automated refraction devices may return unreliable results, as the IC-8 IOL has no specific focal point. So it is important to use a technique such as red-green or midpoint refraction to accurately determine the eye's true refraction. In this video, I will take you through a step-by-step approach for using a red-green balance refraction procedure to determine the endpoint of an eye implanted with an IC-8 small aperture IOL. To learn how to do the midpoint refraction technique for the IC-8 IOL, please see my other video on this method on the AcuFocus University website. The red-green balance technique may be used to find the midpoint balance refraction and is done after determination of a patient's manifest spherical and cylinder refraction and confirming their best acuity. The purpose of this procedure is to determine the correcting spherical lens power in the IC-8 IOL eye. This procedure makes use of the chromatic aberration properties of the eye, which results in shorter green wavelengths being focused in front of longer red wavelengths. The most important things to remember about performing this technique are: 1. Start with a good manifest refraction and a target which is 2 lines above the patient's acuity threshold. 2. Add the red-green filter to the visual acuity chart and, importantly, dim the room lights. 3. If letters in red are sharp or clear, or better focused, add a quarter diopter minus spherical power. 4. If letters in green are sharper or clear, or better focused, add a quarter diopter plus spherical power. Finally, 5. Finish where you have equal clarity between the 2 sides, or 1 click into the red. Even if a patient has a red-green color defect, this test may be utilized since it is based on the principle of chromatic aberration rather than color discrimination. You will need to ask the patient to compare the left side with the right side rather than red versus green. First, obtain the patient's manifest refraction and best corrected visual acuity. Once that is obtained, select the projector's red-green filter with the appropriate target. This can be the 20/40 line or 2 lines above best corrected vision. Place the phoropter in front of the patient's eyes, occlude one eye, and dim the room illumination completely. In general, the procedure looks like this. The patient is asked to compare the clarity of the letters on the red side and the green side. If the letters are clearer on the red side, then add minus quarter diopter sphere. And if the letters on the green side are clearer, then add plus a quarter diopter of sphere. You'll start by asking the patient, which side appears sharper, clearer, or better focused, or do they appear the same? Do not ask which side is better, darker, or brighter. 2 acronyms commonly used to remember this are RAM, red add minus. In other words, if the red side is clearer, then add minus lenses. GAP, green add plus. If green is clearer, then add plus lenses. If the patient says red are clearer, or both appear equal, then you add minus quarter diopter sphere. Continue this until the patient reports equal clarity between sides or until the green side appears clearer. If you don't recall what to add here, try to remember the acronyms I told you about earlier. RAM for red add minus, or GAP for green add plus. Alternatively, if the patient says the green are clear, then you add plus a quarter diopter sphere. Continue this until the patient reports equal clarity between sides, or until the red side appears clear. When the letters on both the red and green side appear equally clear, this is the patient's endpoint for the red-green refraction. In some cases, the clarity may actually switch between the red and green sides, and you won't find a power that leaves your patient with both sides equally clear. When this happens, it is best to leave the IC-8 patient 1 click in the red. In other words, with a slight bias towards the plus side. An important note here is that this actually differs from the 1 click in the green endpoint you might use for a young adult patient with accommodation. You can now remove the red-green filter and recheck their best corrected visual acuity. I've demonstrated the red-green balance refraction technique for use with a small aperture optic, which uses the natural chromatic aberration of the eye. I'd like you to remember the following things when performing this technique. 1. Start with a good manifest refraction and a target which is 2 lines above the patient's acuity threshold. 2. Add the red-green filter to the visual acuity chart and dim the room lights. 3. If letters in red are sharper and clearer or better focused, add a quarter diopter minus spherical power. 4. If letters in green are sharper, clearer, better focused, add a quarter diopter plus spherical power. Finally, 5. Finish where you have equal clarity between the 2 sides or 1 click into the red. Thank you.